Okay, so section 5.10 is actually about sigma notation. So sigma is the Greek letter sigma. And so the letter sigma means sum or to add. All right. So sigma notation, you're going to see this Greek big sigma. At the bottom, this is called the index number. And this number tells you what number to start substituting. This number tells you what number to stop substituting. This is usually a formula. And then this means to add up the terms. Okay? So that's how sigma notation is. It's a really succinct way to tell you to add up a bunch of terms without telling you the terms. So the first thing you want to do is you want to write out all the terms. There are some shortcuts, but typically it won't be very many, so writing them all out is not terrible. Use index numbers and the formula. Then step number 2 is add up terms. Okay? So how to write backwards is they might give us a bunch of terms and then they want us to write them in sigma notation. So we're going to do that once we get to those examples. So let's look at example number 1. Okay. So if you don't like I, you can use X, but notice we have I, we have K. They usually don't use X just because it's not a function, it's a sequence, so they change the letters. They all mean the same thing. So this means if I equals 1, now notice on this one there's no variable, so that means that it's 4. So then I want to start when I equals 1, and then we stop when I equals 10. So next I go to 2. Well, same thing. There's no variable here, so it's 4. And then I equals 3, it's 4 again. And so you can kind of see the pattern. 5, 6, 7, 8, 9. And I want to stop when we get to I equals 10. And it's going to be 4 each time. All right. The sigma part says, hey, add all those up. And so what we really have is 4 times 10, so this equals 40. So the answer is just the sum. This would be like your work. All right? So same idea here, except K equals 4. So what that means is I want to start by substituting 4 into this formula. So 3 times 4 is 12, 12 plus 1, my first term is 13. Then we get K equals 5. So I'm going to substitute 5. 3 times 5 is 15. 15 plus 1 is 16. Then we go to K equals 6. We're going to stop at 9. So I like to map it out. So K equals 7. K equals 8. K equals 9. So if I plug in 6, I get 3 times 6 plus 1. And there is a pattern here. So you can keep going once you find that pattern, or you can keep with the substitution. If I plug in 7, if we plug in 8, and if we plug in 9. All right. And then for sigma, we're going to add all of these up. So I got 123. So there should be some type of work, at least what the terms are, and then what your answer is. All right, so now let's go backwards. So now they give us a bunch of terms and they want to write in sigma. Okay, so our goal is this. You can use K, N, whatever you want. And there is more than one right answer, but if you use the formula, then we're all going to have the same answer. So that's up to you. So step number 1 is you want to find the pattern. Okay, if it's arithmetic or geometric. There are other patterns, but we don't do that in this class. Step number 2 is you want to write the formula. So that's the general formula. So remember, if it's arithmetic, we had a sub 1 plus n minus 1d. If it's geometric, it was a1 times r to the n minus 1. That was from 5.9. And then step number 2 is you want to fill out the index numbers. Now, if you are using the formula, then the bottom one is always going to be 1. So you need to figure out the last number. What did they substitute? Because usually there's some missing terms. Okay, so let's try this. So on ours, I'm going to use the formula. So we got to look at what the pattern is. We're either going to add the same number, or I'm going to multiply. And so it looks like I'm multiplying the opposite signs. So I'm going to multiply by a -1. And then on bottom, I'm going to multiply by 2. So our ratio is -1/2. Okay, so if your signs alternate, your ratio is negative. And so that means that this is geometric. So our formula, I'm going to write it down here, is a sub 1 times r to the n minus 1. So our first term is -1/2. Our ratio just happens to be the same. Use a parenthesis, and then n minus 1. Remember, you want to keep n. Now, there are some things I can do here to clean this up. So we can clean this one up because our base and our number in the front are the same. So this is like -1/2 to the first. And then using exponent properties, we can split this up. That's n -1/2 to the -1. See, when they're the same, you could split those exponents up. So then -1 plus 1, these actually cancel out. So we end up with -1/2 to the n. Now, if you had this as your formula, that would be okay too. So I used a formula, so we know we're going to plug in 1 to get the first term. So then I need to figure out what did I plug in to get that term. So I want to think 2 to what power gives me that 128. And you can try guess and check. So I'm going to try 2 to the 5th. Nope, that's 32. 2 to the 8th. 256, that's too big. So how about 2 to the 7th? I got 128. So because I know the 7th power, that's the last number that I plugged in. And it would be the same thing here. Okay? All right, let's do some more examples. All right, so I am going to actually skip to these two. So I get n, and now this one I am adding 1 each time. So arithmetic, I know my first term, my n minus 1, and then my difference, I'm adding 1 each time. So I get 10 plus n minus 1, so n plus 9. And I plugged in 1. Notice 1 plus 9 is 10. So the last number that I want to plug in here to get 50 would be 41. All right, the last one, let's see. We multiplied by 3 each time. So, and I've got 3 to a power. So I'm going to kind of not use my formula. I know this is 3 to the n. So I want to know the last number I plugged in is 12. And let's figure out what number did they start with to get 1. So 3 to what power gives you 1? Well, that's 0. So there are some different answers if you don't use that.